Hello, Spark fans. Welcome back to Advancing Spark, where I am burning bridges once again today by having opinions on the internet. I know. Who would dare to have opinions? Now, last time I had a bit of a rant. I was talking about data mesh and why it's not really appropriate for a lot of organizations who aren't ready for the sheer cultural shift. Today, I want to talk about a different kind of shift. It's the lift and shift of data vaults into a Lakehouse methodology. And it's something we see a lot. And I am fully aware, daring to talk about data vaults on the internet. Very soon, you're going to see the glow of pitchforks and, kind of torches outside my window as people come and get me. But still, I want to talk about it because we keep seeing it. I keep seeing clients, people in the community, people I talk about, people doing, blogs and YouTube talking about, hey, this is how we implemented a data vault in a lake. And every time I'm like, why? And that's not because of data vault as a process, as a data model, as a methodology for implementing data warehouses. Because I do see the reasons why people have been doing it for years, why people have been building that kind of approach in relational databases. What I don't see is why you take that same approach and apply it wholeheartedly into a lakehouse. That's my argument. Not against data vault itself. If you're a data vault 2.0 practitioner, you do you. I'm not going to criticize. Well, in the open while we're talking to each other. But should you lift and shift that same model into the lakehouse, or should you re-architect? That's what I want to talk about. So if it's your first time here and you're like, what is this guy talking about? Well, just hit like and subscribe anyway, and then go check out the other videos about Databricks and Delta and Spark and nice things about how we do things. Today, we're talking about data vault. So to start off, how do you learn about data vault? Well, there's the Data Vault Alliance, a website run by Dan Linstead. He's the guy that came up with the original data vault approach. Talks a lot about it. Go and find. There's tons and tons of information about it and why and the reasons and the arguments for and against. And one of the things to kind of refresh myself on this today, I was having a skim through here, and there's a whole 45-minute video saying, here are the reasons why you should build a data vault. Now, I'll argue I'm not a big fan of this video, mainly because all of the counter arguments are presented as people say that. And it's not really well argument against, here's why they're wrong. It's other people say this. Whereas, I don't know. I don't like that as an argument as to why methodology is good. I would like, actually, here's a reasoned, structured argument as to why it's good. But you can kind of tell Dan Linstead's been arguing the same point for a long time and is frankly sick of it. So I get it. I get the whole point. So I would suggest if you've never used Vault before and you don't even know what it's about, then read up on it, understand the concept, and kind of get an idea about what it's talking about. But the main thing is saying it's presented as an alternative. It's like the third alternative. We've got Inman, we've got Kimball. It's saying, well, actually, there's a third way of preparing data for managing an enterprise-style data warehouse and getting it, presenting business data to your business. And it's, there's a lot of process in there. It's built for very, very large, complex organizations. It's kind of how it presents itself. All of the examples in there is going, well, there's this example where we had 360 billion records in a dimension. 360 billion records in a dimension probably means you're building a star schema wrong, but I'm not going to get into that argument. There's lots of very large scale. We're talking petabytes. We're talking massive organizations. We're talking huge data problems where they tried to build Kimball and trying to build a conformed enterprise bus matrix, trying to build star schemas across the sheer size and complexity of those organizations was too hard. And so there needed to be a better way to disassociate the star schemas, that kind of like the end analytical models, from the vast changing, swirling maelstrom that was the organization. That's kind of the arguments for it, saying, well, actually, if we break things apart, we can actually isolate change, become more agile, and actually sort of do things in a better way. That's the point. And a lot of it is built around relational style kind of performance. So we're talking about how to do things in a database, we're talking about things in a tabular kind of structure. In fact, in this example, they talk about, what about the data scientists? Well, they go a different way in a lake, and they talk about sandboxing. They talk about having that as a slightly unstructured one. And it talks a little bit about this NoSQL, NewSQL data lakes, but it says hybrid. So it's doing both. It's not saying all together. It's not really embracing the Lakehouse approach. But again, I think this page is from 2019, so Lakehouse is relatively new compared to that. The thing that we've been seeing recently, so Databricks are talking about it, because obviously from Databricks' point of view, Databricks just want anyone to run. If you've got a Lakehouse, sure, you can run it on Databricks. If you've got a Data Vault, you can run it on Databricks. If you've got Star Schemas, Kimball, run it on Databricks. You can do all these things on Databricks. You want to do a data mesh, you can use Databricks to help it. Of course, they are agnostic to the different approaches and modeling approaches people use. I'm not. So the argument here is a little bit, I mean, this is a nice, quick, light primer as to how the modeling aspect of Data Vault works. Again, if you read through the Data Vault 2.0, it's all about not just a data model, it's all about the process and the practice and the methodology for how you implement this stuff. So I'll talk a bit about the model, but it's not just about the model if you're being full Data Vault. But the idea, so the core concept of the modeling point, it's about breaking up business entities into the bits that change, the bits that don't change, the bits that to do with relationships. So you have this idea of hubs, links, and satellites. So any core concept, a data element, a data entity, is going to be broken into these three things. So a hub is essentially just the non-changing primary key of a thing, and also its temporal date. So we have this whole big just list of IDs, essentially. And we're breaking up links is essentially a many-to-many link between these IDs and other items. So again, they've got this thing down below so we can see customers. We have a customer hub, a product hub, and an order hub. We have a link. They say, well, this is how this customer joins those products. This customer bought all these products. These products have been bought by all these customers. It's a gigantic bridging link-to-link-to-link relationship table. And again, there's a three-way thing into orders showing how all those link together. What's called a link. And then satellites is more like our dimensional descriptive data that's extending our kind of hubs with information about the thing in that hub. So for that key, it joins to that satellite entity. Here's all the descriptors we had at that point. So that's the idea. So you've got some incoming data, you're breaking it into these three elements. The idea being, well, your relationships might be changing. That doesn't mean we need to change any of our descriptors. Our satellite doesn't need to change because we're changing our links between things. Where traditionally, if that was a new record and that was all on a single record in a table, we'd have to insert a whole new record with all of the information, its descriptors repeated again, as well as its links, as well as all that information. So by breaking these things up and treating them as different things, we can have a different cadence of change for our links, for our primary IDs, for our descriptive satellites. And it's allowing, essentially, it is a write optimized process. So it is really, really, really focused about isolating change in these objects, allowing us to track the history of change built into these objects, and allowing us to get good write speed, allowing us to get a huge amount of data down into our relational tables as fast as possible without having to flux and change and manage any kind of schema changes and drift up, because we're isolating those as different actual entities when things change. So that kind of makes sense if we are worried about write speed. Now my argument here, and there's an argument in the back in this video where they're talking about, one of the common criticisms of Data Vault is that you multiply out the sheer number of tables, the sheer number of entities that you're dealing with. So in this case, if we had three tables of customers, products, and orders, well, we've now got customers, satellites, products, satellites, orders, satellites, linking tables between them. We are growing, doubling, tripling the number of tables that we have in our architecture to break it up into these facets. Now, from a relational point of view, that doesn't really matter too much. We can handle that, and certainly for write speed, by isolating that out, we can write to these things really, really quickly because we are not writing to the whole object and worrying about if a change happens, it might just change that table, not all three of those tables. That's fine. The argument of performance is, well, actually stitching it back together is slightly harder. I'm now no longer just taking from one table. I'm now having to stitch together three different tables to get what was once the complete artifact in order to build something out. So essentially what we're trying to actually build, we're going from, an inputting object coming in. So if I've got my kind of, my landing areas getting some data coming in from a source, I'm putting it in, and then kind of this concept of raw and business vaults and all that kind of thing. But I'm essentially breaking that up into its component, kind of satellites, hubs, and links. But then if I'm trying to actually build I'm trying to put it back into some kind of analytical model. So I'm saying I'm trying to build a dimension that I used to join 3 tables together. I'm now actually joining many, many, many tables together. So my write speed is adversely impacted by the number of joins that I have. Now, in a relational database, that adding a load of joins, yeah, it slows things down a little bit, but because we can have things fairly optimized in terms of clustered indexes and that kind of thing, we can optimize around it, and actually, it's not too big a hit. For a lake, where traditionally we didn't even do star schemas because adding in the excess joins that you have in a star schema doesn't perform that well. Until we got things like adaptive query execution coming in, which makes those things perform a little bit better, and we can do dynamic partition pruning and all that kind of stuff. That now performs pretty well, adequately. Not as well if you just have a giant flat table, but if you have a giant flat table, that's quite hard to manage in terms of data, and you end up doing massive amounts of inserts. But in this scenario, where we're actually saying what people have to do when they want to write analytics, when they want to explore the data, when they want to stitch things together and work with it, they have a huge amount of work to do to stitch those things together. Performance is not going to be good. And that brings it back down to the point. Why are we building this? Now, in a lot of times when we're talking about kind of the old school traditional enterprise data warehouses, there's a couple of different facets as to why we're building it. One is to actually capture the data somewhere, because we maybe couldn't keep all that data on our source system because it was getting too big, because we were reaching capacity sizes of applications. As a source of record, as an auditable state where we can work out what's happening in our organization if we want a very, very large regulated industry. Plus building analytical models for people to explore and get insights and do all that kind of thing. That's not why people built lakes originally. People built lakes originally because that whole enterprise data warehouse thing was too slowly moving. They're asking someone to go and build a new offshoot, going, actually, there's a new analytical model I need. Building those objects was too slow and too painful and too much work. So actually going out and having something that was deliberately less formal, less structured, and you could spin up things and do very fast, agile analytics, that's kind of the point of lakes. So taking something that's very traditional, very regimented, very, very structured and formally processed, such as Data Vault, building it in a Lakehouse, which Lakehouse compared to Lake, obviously we're getting structures, we're getting auditability, we're getting governance put in there. That's the point of a Lakehouse. And then applying this extra layer of control and regulation and things in there, I don't see the point, because write speed doesn't tend to be the issue that we're looking for in a lake. We don't tend to have major write speed bottlenecks, because we can parallelize quite heavily in terms of how we can write all of this data down onto a disk, which we couldn't necessarily do in a relational engine. Because we can now say, actually, you know what, I need to write quicker, make my Spark cluster bigger for the next 10 minutes and write down more files. I can actually optimize it so I can be writing down huge amounts of data. One of the arguments is, if I've got a star schema and that my business logic changes, you'd have to, the worst case, scrap that and then rebuild it from your whatever staging layer you had in your lake. And that's presented as an absolutely terrible, disastrous thing to happen. And the nature of Spark and lakes is, a majority of the time, if you had to rebuild a model, then you can just trash it and rebuild it by throwing a little bit of compute at it. And that doesn't tend to be the end of the world. It's presented as the worst thing that could possibly happen in terms of a data vault scenario. Now, the example they're talking about is 300 billion rows, and sure, yeah, that would take a long time or need a lot of grunt to do. But that's not how most people are actually dealing with things. The people I've seen arguing that they need a data vault don't have 300 billion records they need to put into a dimension. They're just taking that process and the regime and the methodology and just wanting to apply it. So my question is not saying data vault is not right for any scenario. It's just saying, do you need that level of rigor and process and protection against occasionally having to reload a table? Because there's a lot of work to be able to get there. So other pieces of what we're talking about, so in terms of how it fits in, so according to the Databricks site, in terms of how you might do it, they talk about this. So when we talk about that bronze, silver, gold, the medallion architecture, the Databricks talk about, essentially just saying, well, just jam it in the middle. Instead of having a silver layer, which is kind of normally kind of in line with what your original source system looked like, that's where you want to pull things apart. And then you put things back into star schemas. So we're still getting the end result. The users are still seeing the same thing. We just have this layer of essentially breaking things apart into a data model that sits in the middle, and then pulling things back together into our star schemas. Which again, to me, feels like a lot of work. What's the benefit? People say the benefit is to do with being able to cope with change. I posit that when we're talking about Delta, well, Delta, we have some extra mechanisms that we didn't used to have. A Delta table, we can turn merge schema on, so we can have it gracefully evolve. That table can get extra attributes. It can have extra columns appended to it. It can have data types upscale. That's minor schema drift, minor evolution. We can have fancier things. We can do like the rescue column approach we can use with things like autoloader, where if there is major drift, we get a load of extra data that we never had before, we can capture that as an unstructured column and then still allow people to go and query it and use it. It just simply doesn't have delta star statistics on it. So we can actually encapsulate change a lot more easily these days inside a lake structure than we used to. That's why in a relational database, it was really hard to do that. So having models to protect us against it, it's fantastic. That's one of the major drivers of Data Vault. If we can gracefully evolve without having to do that extra breaking down of the model and the extra complexity of that process, do we need it? And again, there may well be reasons. I'm just questioning it. I'm just saying, has everyone who's applying a Data Vault into a lake thought this through and thought about why they're doing it? So it's one of the big arguments. The other one is for me, process. So it's called out fairly heavily when we look at kind of any kind of Data Vault thing, say, well, you need automation. You know, if you've got kind of your table, so it exists as a single table living in the source system, and I need an ETL script. I need something that's going to break it into my links, my satellites, and my hubs. So that you don't do that manually. No, you build something, you build automation. And my argument against the automation is it's the old style of automation. It's like what I see as the old style of automation. It's the kind of thing that's a code generator. You turn a crank and it spits out a load of code and you deploy those code artifacts. So where we're talking about things like BIML, we're talking about Warescape, we're talking about these data warehouse automation tools that sprung up because of the complexity of things like Data Vault, saying, don't write these myriad scripts on yourself. We'll build something that will spit out all those scripts. Now, my argument there is you still have to look after those scripts. So if I had 100 tables to load, and I've got at least 3 scripts for every single table, then I've got 300 scripts I need to look after. And yeah, they're templated, they're generated, but they're still code objects I need to worry about deploying and managing. If I want to load a new table, I still have to generate that code and deploy that code with the whole DevOps process and automation, all that kind of stuff. The point of Spark, the point of using something like Databricks as an ETL system, is we can build one parameter-driven Python script and say, well, actually, I'm going to pass you parameters at runtime, run this same exact script 100 times for my 100 different tables, and spit out the relevant objects that it needs. That's modern automation. That is data engineering by building a piece of software that can be used as a pseudo microservice to produce data by saying, read something, transform it, and write something automated. So a lot of the arguments for Data Vault are using an old school way of actually automation that's not really the way we're building things in the modern world, but it's how people think about it because it's very process driven. If I've got a script that's metadata driven and I want to add a new table, I add a new line of metadata. I don't need to deploy that code now. I need to deploy the metadata, but I've isolated away my change. I'm no longer having to deploy the core code. Therefore, all of my existing tables aren't being affected by the deployment. And the argument that it's more agile to do things the Data Vault way with this kind of code generation and deployment, aka DevOps process every time I change something, that for me is not more agile than having something that's metadata driven that I can just have based on rules. Someone can go and change those rules in some kind of rule store, and then that pushes things through and the other code have not physically changed. I've not done a deployment. For me, that's more agile. So the different arguments. The final argument for why Data Vault is required is history. It's saying, well, actually, all these historical relationships. When I've got my various pictures where we got that picture up here. I've got this whole concept of my customers, my products, my orders. I've got those linking tables, and I've got the relationship. Well, at that point in time in this hub, that ID was related to that satellite, and that had that state. You can do that without breaking that object up. Because if we're talking about lakes where storage is cheaper, therefore keeping multiple copies of the thing isn't actually the end of the world because it's fairly cheap resilient storage. That's the point of a lake. So if you wanted to be able to rebuild your star schemas with full history, and that's the argument saying you need a vault to be able to do that. I disagree. I don't think you need to. And it's about complexity versus cost. If someone said, I need full history to be able to rebuild my star schemas with all new business logic, and I can regenerate with history, how on earth would I do that? Well, if we talk about that kind of bronze, silver, gold kind of mythology, and I'm putting that through, and I've got my 3 tables coming in, I can keep my silver layer with a full history. So I can, when I merge that in, I can have my current state and then my historical state of all those 3 tables without having to break it up into these different satellites and links and hubs. I can just do that on the actual original source system objects as they came in, which also acts as a bit of a system of record for the original state. And then it's down to me to use that history or not use that history when I'm building out any kind of star schema. So just by capturing the state of the record as it changes and building in essentially what we do as a slowly changing type 2, actually we tend to do it as a type 4 and have a current table and a historical table in our silver layer. Just by doing that as part of our automated Python scripts, I don't get how vaults are going to give us a better history layer than that. Sure, it might be a little bit more efficient in terms of the actual amount of data that we store, but then that's not a big thing in a lake. We're not breaking this thing up, so we're not adding transformation layers. I'm not making my development overly complex. I'm keeping things really, really brutally simple. And I can have evolution baked into it, including evolution baked into that temporal state because of how Delta works. So that, all of those things, is for me the argument as to why you don't necessarily need Data Vault. Data Vault was fixing a problem in relational stores that was very, very hard to manage. So for very big, complex, fast-changing organizations, they found it very hard to do this kind of thing, and they wasted huge amounts of time in terms of rebuilding warehouses and re-implementing, trying to go Inman, trying to go Kimball, and having to scrap it because the business was too hard to manage. With the existing set of BI tools and the existing set of data engineering tools as they were then, I'm yet to see a compelling argument that isn't countered by just this is how Delta works. You don't need that anymore. So again, me not saying Data Vault is wrong if you're using it in Snowflake, if you're using it in a relational database, if you're using it in Synapse dedicated pools, great, you do you. If you are moving a Data Vault into a Lakehouse, I'd question saying, what are you gaining? I mean, sure, the simplicity of doing a lift and shift, if you've already got all that logic and all the process works, yeah, lift and shift it and run it in a Lakehouse, fine. But if you're rebuilding and remodeling and doing a load of stuff, would you pick Data Vault again if you're in a Lakehouse style technology where you're using Spark, you're using Delta, you've got all those modern benefits of that tech stack? What are the arguments for using Data Vault? And that is what I've not seen convincingly. Sure, there's some process benefits, there's some methodology benefits, but not enough to say, well, the overhead of adopting all of those additional rules, those constraints, those things which slow down agility and prototyping in business and data science. Yeah, it sits on the outside. It's not part and parcel of how all that stuff works. What do you get if you put all that stuff in? What are the benefits that aren't already given to you by all of that existing technology? That's the simple thing that I have not yet been convinced of. So if you have arguments, if you've come across it, if you've built it in a lake and you're like, you know what, actually, Simon, you are wrong. Here's a load of really convincing reasons why there's a point to having Data Vault in a Lakehouse, I'd love to see it. I'm always happy to be wrong and go, you know what, no, actually, I take it back. That has real intrinsic value. That's something that a Lakehouse cannot do without this methodology and the modeling and the process that comes in Data Vault. Haven't seen it yet. I hope someone shows it to me. Otherwise, if I don't, I hope people stop coming to me and asking me if they should build a Data Vault in a Lakehouse, because my answer is a resounding no. Why? It's a load of extra work. What are you getting out of it? Cool. Well, that's going to have offended a ton of people when I butchered all the processes and ideas behind Data Vault. Apologies to those if that is you. And yeah, as always, don't forget to like and subscribe, and I'll see you in the future when I next get annoyed about something and decide to have a rant. Cheers.